right. Hi, guys. I decided to record myself for the new lesson just because I'm not going to be here. And I didn't want you to fall behind. So instead of giving you a makeup day, I'm teaching. So I want you to make sure that you have your headphones out and put on your head because I want you to listen to this. This is important. And then make sure your notes are out because I do need you to take notes and get ready to just listen and take notes. All right, anyways, let's get started. So I want you to open up your notes to the printout notes that I gave you. We are going to be talking about the last form of quadratic functions. We talked about vertex form, we talked about standard form, and now we're going to talk about factored form. It's also, might be called intercept form, but we're going to call it factored form. So today your objective is you will find the x-intercepts, which we know the x-intercepts is where the graph crosses the x-axis, and the axis of symmetry, which we know is the invisible line that splits the parabola in half. And we're going to do this by using this formula. This is factored form, and if it's in factored form, the A represents, either the graph is opening up or it's opening down if it's negative. And then it also tells us if it's fat or skinny. And then the P and Q here, those variables represent the x-intercepts. And then the axis of symmetry is the halfway point between the x-intercepts. So if I have a graph like this, it's not going to be pretty. But our x-intercepts are here and here. This would be our P and Q value. If let's say this is -2, that means P is -2. And let's say this was 3, then that means Q is 3, or vice versa. You can call this P or you can call this Q. So those are the x-intercepts. And then the axis of symmetry is the halfway point in between them. So what you would do is you would say, okay, well, P plus Q, you would add this total up and then divide by 2 to find the middle part. And that's where this formula comes. So this one I kind of drew it bad, but any parabola, you take this point, P and Q, you add them up, divide by 2 to find the middle. So let's go ahead and use the problem that you have on your notes that I gave you. This problem right here is in factored form. F of x equals a times x minus p and x minus q. So with this, we can label our A. A is -2. And if our A value is negative, we know that the graph is going to open down. So it opens down. It looks something like that, opening down, because it's negative. And then here, our P, for this one, the formula is supposed to be x minus, and this isn't minus. So that means P is actually -3. And that's because x minus, which should be part of the formula, -3, is the same thing as x plus 3 because two negatives make the positive. So this would be x, this would be minus, and our P is -3. So let me just highlight that for you. P is -3. And then here, our Q, it's x minus is already there, so we don't, that makes it easy. And our Q is going to be 1 here. Q is just 1. So now, if we were to find, if we wanted to know what the x-intercepts are, we actually have them because P and Q are the x-intercepts. So that means on our graph, 1, 2, 3, this would be -3, and this would be 1. We know that our graph is going to cross at -3 because this is our x-intercept, and this is our other x-intercept, and 1. We also know it's opening down, so it's going to look something like this, and we can actually find the axis of symmetry because the axis of symmetry is halfway between the two x-intercepts. So if we plug into this formula, it's going to be x equals P, but our P is -3, plus Q, and our Q is 1, all divided by 2. Well, -3 plus 1 is -2 divided by 2, And negative 2 divided by 2 is negative 1. So even though I didn't draw the picture very good, our axis of symmetry is x equals negative 1. So it's going to be right here at x equals negative 1. That's going to be the invisible line that cuts it in half. And so that's how you find the x-intercepts and the axis of symmetry for something that's in factored form. You also, once you have the x, we know that the vertex has the same x value as the axis of symmetry. So we know our vertex is going to be negative 1. And then we would plug that x value into here to find the y value. So it would be f of x is the same thing as y. So it'd be y equals negative 2, x plus 3, x minus 1. I'm just going to go and show you. So it'd be y equals negative 2. We're going to plug in our x. Our x value was negative 1. Negative 1 plus 3 times negative 1 minus 1, which turns into negative 2 times negative 2, which gives me, and I think you probably can't see this at this point, this gives me y equals 2 negatives make positive. 2 times 2 is 4. 4 times 2 is 8. So our vertex would be negative 1, 8. But if we took this and graphed it into Desmos, I'm going to go ahead and go to the graph. I already typed it in Desmos right here. You could just type it. I changed the f of x to y. You can keep it f of x. You also don't even have to put it. So if I take away the y right here, you'll see it's still the same thing. So if you zoom out, you'll see our x-intercepts, if you click on it, was negative 3, which is what we got, and 1, which is what we got. And the axis of symmetry is the line that cuts it in half right here at negative 1. That's the halfway point. And if, as you see, we got the vertex, which was negative 1, 8. So that's how you use factored form to find the x-intercepts, the axis of symmetry, and you could even find the vertex. So let's go ahead and try a few problems. So let's go to the next problem. Go ahead and write it down, this one, because you don't have it written down yet. And we are going to find, it says to find the x-intercepts, which is also the zeros. So if your problem or your homework asks for the zeros, then it's asking for the x-intercepts. And we're finding the axis of symmetry. So we're going to use factored form. So I'm going to go ahead and write factored form right under it. I'm going to change f of x to y. It's the same thing. Y equals a times x minus p times x minus q. Sorry about my sloppy writing. So we're going to find the x-intercepts first. The x-intercepts are the p and q. It's right here. So p and q, if we can find our p and q, then we know our x-intercepts. And our p, it has to be x minus, and it is x minus. Our p is 3, and our q would actually be negative 5, because it should be x minus negative 5, because 2 negatives make that positive. So our p is 3, and our q is negative 5. Also, I'm going to go ahead and label the a value. The a is the number here, and it's negative, so there's an automatic 1 there, which means we know the graph is opening down, something like that. But we know our x-intercepts, so we can say the x-intercepts, sorry, my writing is so sloppy, the x-intercepts, or the zeros, same thing. The zeros of the function is the coordinate point where it's going to be 3, 0 and negative 5, 0. Because we're finding the x value when y is 0. That's also why it's called the zeros. So these are x-intercepts, p and q. I'm not sure if your homework is making you just type in 3 and negative 5, or if you have to write it as a coordinate point. So I'm going to do both for you. So that's our x-intercepts right there. And then we also have to find the axis of symmetry, which the AOS to find the axis of symmetry we use right here. It's the second bullet point. The axis of symmetry is the halfway point between these two. So you add them up, you use the formula P plus Q, then you divide it by 2 to find the middle. So P is 3, Q was negative 5, and we're going to divide both of those by 2. So 3 plus negative 5 is negative 2 divided by 2, which is negative 1. So our AOS is an equation at x equals negative 1. And I'm going to go ahead and just verify in Desmos to kind of give you a visual of what it looks like. That's our old graph, and this would be the new one. If you graph it and type it in, you'll see, if you zoom out, our x-intercepts are where the graph crosses the x-axis, which is right here. So it's going to be at negative 5, 0. See how it's written as a coordinate point, and 3, 0. Then the axis of symmetry is the line that splits in half, which you can see if this is the vertex, our vertex is negative 116, which means our axis of symmetry is negative 1. All right, I'm going to do one more. So let's go back to one more problem. Go ahead, write it down. And we are going to do the same thing. We're going to find the x-intercepts, also known as the zeros of the function, and we're going to find the axis of symmetry. You could graph this to see them, and I think graphing it is a good visual, but you don't have to graph it to find these answers because it really is as easy as just labeling your P and Q and then dividing them by 2 to find the axis of symmetry. So I'm going to go ahead and write factored form, the formula. I'm going to change it to y equals a times x minus p and x minus q. Again, remember the p and q are the x-intercepts. So I'm going to just highlight this. So if we label it, we can rewrite this as x minus negative 5 and x minus negative 1, because the minus has to be part of the formula. So we can see here our p, so x minus p is negative 5, and q is negative 1. So I'm going to go ahead and label them. The x-intercepts is p and q. P and Q. So it's going to be, if we write it as a coordinate point, it would be P, which is negative 5, comma 0, and Q, which is negative 1, comma 0. This is also called the zeros because it's when y is 0, right there. So our x-intercepts are negative 5 and negative 1. That's where it's going to cross the graph at. I can actually graph it by hand pretty fast without using Desmos. And then we're going to find the axis of symmetry. I call that the AOS, axis of symmetry, by using the formula. You take the two intercepts, divide them by 2. So it's going to be P, which we said P was negative 5, plus Q, and we said Q was negative 1, and we're going to divide them all by 2. We're going to cut them in half. This gives me negative 6 divided by 2, and negative 6 divided by 2 is negative 3. So the axis of symmetry is x equals negative 3. And I'm going to verify it with Desmos again. I could graph it by hand, but if we're going to check Desmos, if I highlight the problem that we did, which is this one right here, you can see it's crossing the x-intercepts are negative 5 and negative 1, which is what we got. And then if you add those together and divide by 2, you'll see the axis of symmetry is the invisible line that cuts it in half right here. And you can see it's at negative 3, which is what we got. So that's how you use factored form. I kind of think this one's the easiest one, but not all quadratic functions are in factored form. So I'm going to have you try this in your groups normally, but you have your headphones on and you're not paying attention to anyone else. So go ahead and try this problem. Label your P and Q, your x-intercepts, and then go ahead and solve for the axis of symmetry. All right, that should have given you time tried to put in your answer. I'm going to verify for you, just show you real quick. When you type that function in, you get this one. We know that the graph is going to open up because our a value is positive 3. Our intercepts were 3 and 5. And the axis of symmetry, if you divide that in half, is 4. And you can see the axis of symmetry is 4. And that's it. So what I want you to do now is work on big ideas. It's called factored form, zeros, and axis of symmetry. And you're going to do the same thing that I just did in these problems. Have fun.